Welcome back, guys. So here we will try to understand how deletion works in case of linked list, right? So first I'll give you the background of everything and then we'll start with the actual coding so that you can understand very well. So if you look at the array list, okay, let's say this is your array list and you have to delete the data from this index second. So what will happen here when you delete the data from here, again the internal shifting will happen. So how internal shifting will happen is the third will come to second, okay, fourth will come to third and fifth will come to fourth. So a lot of shifting is happening. So performance wise this is not good. When you delete the data from the array list, if you delete from the beginning, entire array list shifting will happen. Like let's say if you delete this data, right, then entire array list will get shifted. 1 will come to 0, 2 will come to 1, 3 will come to 2, 4 will come to 3 and 5 will come to 4, right? Yes, there is one advantage and you have to delete from the end of the array list. There is no shifting, okay? So there is no shifting. If you have a requirement where you have to delete from the end of the array list, there will not be shifting. That is the reason deletions in the array list, we always say it, the worst complexity is big O of n. N is nothing but the length of the array list, okay? That could be the worst case where you are deleting from the beginning, so entire array list will get shifted, and n is the nothing but the size of the array list, so the worst case complexity is going to be big O of n, okay? Now the best case can be a lot of things, but best case can be 0 of 1 also, where let's say you have to delete only from the end. If I have to delete 5, right, my complexity will be big O of 1, because in the constant time this will get deleted. Just I need to run only one time a loop and I can delete that, right? So the complexity will be very good, right? Now let's see that how it works in case of linked list. Linked list deletion is awesome. It's always very fast. So look at this linked list. Again, go back. Look at the array list. You have to delete index 0, means entire data will get shifted. And in this case, your complexity will be always big O of n. When you are deleting from the beginning, always complexity big O of n. But in case of linked list, when you have to delete from the beginning, let's say I have to delete this node 20, right? What I have to do? It's very simple. First, I need to store the address. So let's say this guy address is 10, okay? So head will be pointing to 10, okay? Now this guy address is 20, right? So 20 will be here. Now this guy address is 30, so 30 will be here, which means the first node reference is 20, which means it is pointing to this node. The second node reference is 30, which means it is pointing to 30, and this complete node address is 30, this complete node address is 20, this complete node address is 10, right? Now what I have to do, I have to delete from the beginning. So just the thing is, what I have to do, head is pointing to the first node, so I need to create one temporary variable. After creating a temporary variable, in temporary variable, what you do, you store the reference of the next variable. So need to go back. Yeah, so what you have to do, this temporary variable will basically store the address of 30, right? And then what you do, your head is equal to temp. So when your head is equal to temp, head will come here, then automatically the reference of this node is over. Now a reference of this node is over, okay? See, this is one way of doing that. The next things what you can do, that is you can move the head is equal to head dot next. So there are two things you can do, that you can do head is equal to head dot next, means it will be pointing to 30, and this guy temp variable is pointing to this guy. Now what you can do, that is you can do temp, this temp is equal to null. Okay, the moment you will do temp is equal to null, the garbage collector will remove this object from the memory because this is not referenced anywhere, so this will get deleted. Now if you look at here, when these deletions happened, does it has any impact here? No. Still 30 is pointing to 40, no memory, no reallocations, right? Just the thing is, head was pointing to 20, now it is pointing to 30. And you know that in linked list, always the first node, always the head node is the first node, which means in the linked list, always the head will be pointing to first node. So here if you look at the performance wise, there is no problem at all. There is no internal change, just address change happened. Okay, so performance wise, what is the performance for the insertions at the beginning in case of linked list? Big O of n, it's very fast. Okay, it's like very fast. There is always big O of 1 constant time. Okay, which means constant time, like only one time you need to add the things, and performance will be very very fast when you are deleting, right? Now when you are deleting the last node, see here, to be very honest, when you have a requirement to delete the last node in case of linked list, it is bit expensive compared to array list. In array list, if I have to delete the last node, okay, I can just go based on the index, I can delete this, no problem, I can delete in case of array list. In case of linked list, the problem is I cannot go to the last node straight away. There is no way, I cannot go there. So what I have to do, I have to start from the head dot next, check if this node is pointing to null, no. Again dot next, check if this node is pointing to null, yes, this guy is pointing to null, which means this is the last node, this guy is the last node, and this guy is the previous to last node, right? So now you need to store this reference into some variable. So you can look at here, previous to tell node, and this is the node to be deleted, the last node I have to delete. So what I have to do, that is, now this guy should point to null. Why this guy should not point to null? So there will not be any reference between this object, this node, 30 node and 40. There should not be any reference, and so when there is no reference, automatically this object will get removed from the memory by the garbage collector, right? So if you look at here, the deletions in case of linked list at the end, always the time complexity is big O of n. What does mean by that is, always you have to actually come till the end of the node, right? So for that you need to run the loop, you need to run any loop, for loop or while loop or anything, okay, and then you need to come here. Once you reach here, then only you can delete the last node. So here the time complexity is big O of n, that is what's time complexity. You have to travel, n is nothing but the size of the linked list, n is the size of the linked list, so you have to travel n times. Okay, now let's say you have to delete at the middle also, that also time complexity will not be constant time, and it will not be big O of n also, because you are deleting in the middle. So if you look at here, this is your linked list, the first node head is pointing to the first node, then 30, 40 and then null. So you have a requirement, right, where let's assume that this linked list where you have 4 node, 20, 30, 40 and 50. Now you need to delete this. You have a requirement where you have to delete the node which is at position 2, right, which is at position 2. So this is 0 positions, this is 1 positions, this is 2 positions, so I have to delete this. So when I have to delete this, okay, so to delete this, first what I have to do, I need to come to that positions. So to come to that positions, I need to write some loop, I need to run the loop. So by running the loop, what we will do, we will run the loop one less positions than the node to be deleted. So if I have to delete the node second, I will run the loop only till one index. I'll come here, this is my previous node, okay, and this is the node to be deleted. So what I'll do now, I'll be here, I'll be storing this object into some reference, okay, some reference. So let's say I'll be storing to, let's say, temporary is equal to 30. Now my 30 was pointing to 40. Now what I have to do? I have to do temp dot next is equal to, right, temp dot next is equal to what? So the temp dot next is equal to temp dot next dot next. That is one way you can do that. Temp dot next. So the temp, this is the temp dot next is this, and then next is this. So first change the reference. Okay, now 30 will be pointing to 40, right? Then whatever node dot next, so this guy, this dot next should point to now null. Automatic this reference will go over. So when this guy is pointing here, there is no reference, and you are closing this also because this guy is now pointing to, so let's say, this node which need to be deleted. So deleted node should be null. So when you do deleted node is equal to null, now this guy will point to null, which means this has no reference at all. See here 30 is now pointing to 40, so this will get cleared. Okay, so here also deletion again, it will take some time to come to the particular node, and then we need to delete that, right? So in worst case, again the complexity is going to be big O of n when you have to delete at the end, but when you don't have to delete at the end, the complexity will be lesser than the big O of n. If you have to delete at the beginning, of course it's a very best approach, where deletions in the beginning is always constant time because you need to delete this. Deletions at the end expensive, big O of n. Deletion in the middle, n log n. Okay, different time complexity. Okay, maybe you'll be wondering that complexity concept and all that. Here you just try to understand that's where I'm not going to the details. Here just try to understand big O of n means n is the size of the linked list, so you have to run the loop to the complete size. When I say constant time, which means you don't need to run the loop. Here you don't need to run the loop because you need to delete the head node. Here you need to delete the last node, so you need to run the loop. So that's how deletion works, guys. Okay, so we learned about the insertions, we learned about the deletions. Now in next video we will start with actual method of linked list, and then we will go into deep into that. Thank you guys, thank you for watching this.